Thank you for tuning in to the Math Guy. Today we'll be looking at compound interest. Our first problem for today reads, determine how much interest will be paid on a loan of $7,500 at a rate of 0.5% compounded daily for 7.5 years. Our formula for compound interest is a little bit more involved than our formula for simple interest. Our formula for compound interest looks like this. FV equals PV times the quantity of 1 plus R over N raised to the N times T power. Because of this, we have a couple more variables we have to look at. Some of them might be unfamiliar to you. The first thing we have here is FV. FV stands for future value. This is how much it's going to be worth down the road. This is usually involving how much you have to pay. It's usually the same thing as your maturity value. So, if we want to write here, same thing as maturity, which we saw in simple interest. It's principal plus compound. We also have PV. If you look back to simple interest, this is the same thing as your principal. Okay? So the amount of money that we borrowed is the same thing as your present value. If you look, we still have a lowercase r. This is the same thing as our interest rate, which was represented by a capital R in simple interest. We also have a lowercase t, which is the same thing as your time, which was also represented by a capital T in simple interest. The only other new piece of information we have here is lowercase n, which, in case you didn't know, represents the number of times the loan's compounded in 1 year. So if you look up here, it says compounded daily. Daily simply means 365 days. So if we go through, we can start getting rid of some of this information now. I already went through all these different variables. We can start using these pieces of information to find out what is what. Well, we said that n is simply the number of times it's compounded per year, which we already found up there was 365 days, which is 365 times. T, if we're talking about the number of years. It says here 7.5 years, so T is 7.5. Lowercase r represents our interest rate, which is 0.5%. So we have 0.5%. 0.5% is a decimal, just happens to be 0.005. Okay, not much. It's a low interest rate, but it's about common for right now. So we'll leave that as it is. PV, I said, was our principal, which is how much we borrow. We borrowed $7,500. Well, if we know 4 things, we can find the last one, which is what we need to find. We need to find out how much interest we applied. Well, remember I told you that FV is the same thing as maturity. So we have to go through and actually subtract 7,500 to find out what our value of FV is. So we'll do that at the end. So we just start filling all of this information here into our formula. So we do this, we end up having something that looks like FV equals 7,500 times 1 plus 0.005 over 365 raised to the 365 times 7.5 power. Now the numbers look pretty big, but if you're worried about it, your calculator will handle it. Your calculator can do this problem. Don't sweat it. Just work through it slowly. We'll break it down into pieces, which is the best way to do this problem. So we start simplifying things down. We're just going to let the 7,500 go for now. We're going to work inside these parentheses here, and then we'll work in the exponent so we can have all of this broken down in a systematic manner. So, first thing we have to do is 0.005 divided by 365. Your calculator will do this problem easily. If you type in 0.005 divided by 365, you'll get 0.000014. It's a really small number. After this, we also want to break down this exponent we have. So we do 365 times 7.5. We will get 2,737.5. So that's our power. The problem is breaking down a little bit more. So let's start combining some like terms. So Once again, we're going to leave the 7,500 go. We have 1 plus 0.000014, which just happens to be 1.000014, raised to 2,737.5 power. So, if we follow the order of operations, the next thing we have to do is the exponents. So, once more, leave the 7,500 go. Type into your calculator 1.000014 to the 2,737.5 power. We do all this, we get an answer of 1.0391. Didn't really change much. But for a lot of these problems, it doesn't. Our last step to find out what our future value is, we simply take care of any multiplication we have in our problem. So in your calculator, do 7,500 times 1.0391, and you will get an answer of $7,793.25. Our answer, our problem, it says determine how much interest, so which means we need to find out our value of I. Well, we know that our FV is the same as our maturity value. So we take FV and subtract our PV. So we take 7793.25 and subtract our value of PV, which is 7,500. This will give us our value of I, which happens to be $293.25. $293.25 is how much interest you will get on a loan of $7,500 at a rate of 0.5% compounded daily for 7.5 years. Our next problem for today reads, determine the present value of a loan if the future value of the loan is $6,000 at a rate of 5% quarterly for 6 years. To do this problem, we're working backwards. If we look at our formula, which happened to be FV equals PV times 1 plus R over N raised to the NT power, this time we're told the future value. We want to find PV, which means we have to do some algebra to work backwards. So if we want to find PV, we need to know FV, we need to know R, N, and T. So we read through our problem. We are told the future value is $6,000. So we can put that in for FV then. At a rate of 5%, so lowercase r is 5%, which happens to be 0.05 as a decimal. It says quarterly. Okay? Well, there's 4 quarters in a dollar. Quarterly means 4. So lowercase n is 4. And it's for 6 years. T is always the number of years, so T equals 6. So we have all this information. We start going through and filling it into our formula. So we fill in what we know, leave anything else blank as it is. So we know that FV is 6,000. This equals PV, which we don't know, which I said we'll leave as PV, times the quantity of 1 plus R over N. So we have 0.05 over 4, raised to the NT power, which happens to be 4 times 6. So a lot of this we can go through. We can go through and actually simplify everything down just like we did before. We just have one different step at the end. So leave the 6,000 go. PV just stays as it is. And we work inside of these parentheses here. So we have 1 plus, we take 0.05 on our calculator, divided by 4, and we get 0.0125. This is raised to the 4 times 6 power, which happens to be in parentheses. 4 times 6 happens to be 24. Our next step, we just go through and we break some more stuff down. So 6,000 stays as it is, PV stays as it is, and we have 1 plus 0.0125. It's easy addition. It's 1.0125 raised to the 24th power. Our next thing we can do is take care of our exponents, just like the order of operations. 6,000 and PV stay as they are again. 1.0125 raised to the 24th power. You can do that in your calculator. You should get 1.347. Our last step, we want to get PV by itself. So we divide each side by 1.347. The 1.347s cancel out. We're left with just PV. And 6,000 divided by 1.347. If you do that on your calculator, you should get an answer of $4,454.34. $1,454.34 is our present value if our future value is going to be $6,000 at a rate of 5% quarterly for 6 years. Our last problem for today reads, determine the compound interest rate of a loan if the present value of the loan is $1,000, the future value is $1,500, and it's compounded quarterly for 3 years. For this problem, we have to go through and determine the compound interest rate. This problem is going to be a little bit different than the other ones because the formula cannot be used from the last two problems. For this one, we have our own formula that makes it a little bit easier. The last formula could be used, but it's very tricky to break it down. I already solved it for you. The formula looks like this. R equals FV over PV raised to the 1 over NT power minus 1. So, just like the other problems, we know we want to find R, which means to find R, we have to know FV, PV, and T. So let's go back to the problem and see which piece of information we have and what we don't. So, FV, it tells us here that FV is 1,500. Tells us that PV, or present value, is 1,000. So we have those two. We have half of the information we need. It says that it's compounded quarterly. Just like the last problem I said, compounded quarterly means that n equals 4. And it says 3 years. So T equals 3. We have all the information. We can plug it into this formula here and find out what lowercase r is. So we start filling stuff in. We know that R equals FV, which is 1,500, divided by PV, which is 1,000, raised to the 1 over n times t power, so it's 4 times 3, all minus 1. Okay, this problem looks a little bit tricky. You're like, huh? Raised to the 1 over 4 times 3 power? What's that mean? It just means we have a decimal as an exponent, which our calculator can do that as well, which we will get to that in just a moment, but you raise it to a power just like we did in the last problem. So we start breaking down everything we have. 1,500 divided by 1,000, you can do that in your calculator, you get 1.5. Raised to the 1 over 4 times 3 power, 4 times 3 is 12, minus 1. Our next step we have to go through and do is break down this 1 over 12 power. So R equals 1.5. On our calculator, we can take 1 divided by 12. We'll get a decimal, which just breaks down to 0.083. Our next step is simply just follow the order of operations. Take care of the exponent. So R equals 1.5 to the 0.083 power. 1.5 to the 0.083 power is the same as 1.034. So we have 1.034 minus 1. Do the subtraction. You can do it on your calculator if you must. But we get 0.034. 0.034 is the same as 3.4%. So, we determine the compound interest rate, which is 3.4%, if the present value of the loan is $1,000, the future value is $1,500, and it's compounded quarterly for 3 years. Thank you for tuning in. Remember to check back again soon for more videos by me, the Math Guy.